Welcome to the webinar, Management Strategies in the Field to Improve Size and Uniformity in Mango Fruit in Ecuador. My name is Cesar Favero. I'm the Industry Relations Manager, and I will be the moderator for this webinar. In order to get started with our discussion regarding management strategies in the field to improve size and uniformity in mango fruit in Ecuador, allow me to introduce our speaker for today, Dr. Ítalo Cavalcante. Dr. Cavalcante has a doctorate in plant production from UNESP in Brazil, and he's an associate professor at the Valle del São Francisco Federal University in Petrolina, Brazil, where he also leads the Fruit Vast Research Group. He is an instructor of the graduate program in agronomy, and he researches physiology in mango production, focusing on nutritional management and biostimulation. He is also a founding partner of Plant Soil Laboratories and Robisco Agroscience. Welcome, Dr. Ítalo Cavalcante. Please go ahead. Hello to everyone. I would first off like to thank the National Mango Board for this invitation, and I would like to thank the National Mango Board not just for this invitation, but also their confidence and their support. Not just in this research project that I'm going to present to you today, but also for all of their support. And I would also like to thank the mango industry in general, members of the supply chain who have supported my research projects, which support is extremely important. And to get started with this topic regarding strategies to increase fruit size in general is a very important topic. It's a topic that limits fruit quality and markets and the window of production and marketing and the ability to sell fruit at higher prices. This is an extremely important topic, and I'm very aware of how important this topic is, not just for Brazil. During certain times of the year here in Brazil, we have similar problems, but this problem only occurs in Brazil when there are two factors present. One is when the fruit load is much higher than expected. And when this happens, we see a significant problem. And not just that, it's the quantity of fruit. But there's also the issue of the time of year, because I know that in many countries, there's a certain window of production. Each country has its production and export window for the US and Europe. Here, however, we produce and harvest year-round, every week of the year, as a result of management. But there's also a problem with that. And it is that, for example, when we see somewhat lower temperatures, which are necessary for this fruit to grow, often the fruit does not develop well due to light quality and quantity of light, but also due to stress. When the mango tree is more stressed, we have seen this many times, when mango trees are under greater stress and the level of photosynthesis goes down more, we see a reduction in metabolism, the rate of metabolism. And so the absorption of water and nutrients also goes down. And as a result, the fruit size goes down as well. But I have seen that in other countries, this issue also occurs, but differently. There are different factors in play, different causes. So this is generally the first slide that I like to present. And this is the first stage for evaluating fruit size, if it's large or not, if it's of a good size or not. We have to understand genetically when the variety that you're working with, we have information for Tommy Atkins here, which is the primary variety that is produced in Ecuador. So we're seeing here 400 to 600 grams. So not all fruit has to reach 600 grams. I'm not saying that. What I'm saying is that it can reach 600 grams, or it could be 400, 450, 500 grams. So if we're not seeing that size of fruit, what's going on? So the first stage in this type of situation is to understand the orchard in all of its aspects, the weather conditions, what the grower is doing, what you're doing in terms of management, weather management, also to understand the nutrition, the water, the quality of the water. I was in Peru recently, in recent weeks, speaking at the UPM conference. And also one of the seeing a limit on the fruit size, but there are different conditions and different causes than in Ecuador, which is fantastic for me as a researcher because the reasons are different and the management is different in different countries and different regions, even countries so close to each other. And the management is completely different and the recommendations were completely different. So during the first stage, it is important to ask the question, is it possible to have a larger fruit, to produce larger fruit? Here we're looking at Tommy Atkins. This is a good sized fruit. And that can reach 500, 550 grams, a little more or a little less. There are other problems in the mango production system, yes, of course. But I have included here in yellow with a yellow background, which is fruit size. So most countries have problems with fruit size. And of course, it depends on the variety. Why does it depend on the variety? Well, because some varieties, such as Keat, as we all know, is a variety that tends to have larger fruit. In recent years, we've looked at an experimental orchard with different varieties, the primary varieties, and with different rootstocks. And what we're seeing is that Keat, for example, is a variety in which the fruit size does not depend much on rootstock, but other varieties are influenced by the rootstock. And Keat is very efficient in terms of its use of nitrogen. It's really tremendous. You apply even a small dose. We're talking about 20, 25 for the entire orchard. And even at times we apply less than that. And the fruit still reaches larger sizes. But Tommy is different from Keith in this sense. This does not apply to Tommy. And one of the main reasons for that is genetics. Keats are genetically more efficient. So my hypothesis is that there are certain enzymes and a specific enzyme in which Keat has a much higher level of activity, so its metabolism is much faster. Metabolism of nitrogen, specifically. And that does not occur with Tommy. But what's the case? What happens with Tommy's? And this is information that I've presented to growers in Brazil 2 weeks ago, and I spoke about this in Peru as well recently. What we're seeing here is that supplementation of molybdenum can accelerate nitrogen metabolism, and this had a very interesting effect in Tommy in terms of flowering. And so if we see a positive effect on flowering, then that means that it had an impact on this enzyme that accelerates nitrogen metabolism. So molybdenum has also become part of the recommended agents to improve flowering. And it has a very short effective life when applied, but it's very necessary. So we have the variety that has natural vigor, which has an impact on fruit size. We also see the age of the fruit, pests and weeds, and root system. Root system is also very important because the root system, well, I put this down here. I put root system here because the root system defines the tree's ability to absorb nutrients, water, and all the different elements, fertilizers, anything that you apply. The root system affects bioabsorption in mango trees. So this is a photo of a root system in a mango tree. And this is a photo of the root system between two different trees. And you can see this is an intertwined root system, and it's not very deep. This is very common. And you can see here that it's not a very deep root system. And this has a good side and a negative side. The advantage is that if you apply water frequently and water is readily available, it's an advantage to have this type of root system because whenever you apply any other element, it dissolves easily. And then the downside is if you have certain types of irrigation, this type of root system will suffer quite a bit. So I'm showing you this root system that works for high productivity. So I'm talking about Tommy over 35, 40 tons per hectare. So looking at the root system is extremely important. This is another situation that I've seen, and I've included this information in the project, which is the mango fruit development curve. Because we have data, and this applies to each country and each variety. What we're looking at here is a curve, and down here you can see it says days after second fruit drop. So this is a normal physiological stage, physiological fruit drop. So this was done during the first fruit drop. So when the fruit was of a certain size, 45 millimeters in diameter, so very small. And so here we're looking at the diameter. And I put this here as an example, this measurement, but this was done with measurements every 15 minutes and with real-time transmission so that we could analyze what was happening in real time. And what we saw was that the mango fruit, when it's on the tree, it grows very quickly during the initial weeks. And here we're looking at distances of a week, 1 week, 2 weeks, 3 weeks. So during the initial growth weeks, it's very rapid and then it continues to grow. But look at what happens here. Up to the last 2 weeks, during the last 2 weeks, there's very little fruit growth. There's some fruit growth, but very little. And during the last week, there's really practically no growth, almost no growth. And if we're talking about weight, well, look here. Here's the fruit weight during the last week, close to the harvest point. Almost no increase in weight. So thinking about distribution of fertilizers, when should I apply fertilizers, potassium primarily, thinking about the size of the fruit? So from a logical standpoint, it would be during this phase here, when this curve is going up, because when it's going up more steeply, we're talking about a higher growth rate. So this works very well. This system works very well to give us an idea. So generally, management is extremely important in mango production because you have climate, weather conditions, and growers here in Brazil and all over the world talks a lot about the climate and weather. Yes, that's true. But what are you doing to protect your trees from the weather? And what's going on due to lack of water or too much water or temperatures, high temperatures, low temperatures, or light intensity if it's stronger or weaker? What are you doing in response? And I talk about this with growers quite a bit. You know that that weather, that climate is a challenge, and that's not going to change. It's difficult by nature. So there are things that we can do to improve this and to respond to this. So we have different factors here, management of irrigation, and this also has to be managed in accordance with the growth curve. And this growth curve works very well, especially when the flowering is uniform, because that means that fruit development will also be uniform. So we have here irrigation, use of hormones. There are two important hormones for fruit growth, primarily divided in the first growth stage where there's cell multiplication, and then in the later stages to increase diameter, which would be gibberellins. And the primary nutrients are potassium, but also nitrogen is extremely important. Also thinning, which works very well for Ataulfo. And also there can be financial challenges, and many countries are facing difficulties with labor. That is very difficult and very complicated. So thinning is an important aspect. And you might say, but thinning can be done by chemical methods. Yes, that's correct. But I think it represents a huge risk. I'm concerned about that because it is very difficult to achieve uniform flowering and then to selectively reduce the fruit. I'm concerned about that. Roots, root frequency and availability, and how to multiply roots in order to promote growth, and photosynthesis. How do we work with photosynthesis? Because the rate of photosynthesis has to be high in order for the fruit to grow. I always include this factor because this has always been and will always be an important factor. Potassium in the pulp is also an important factor, and in the peel. The greater the amount of potassium in the pulp and the peel, the higher the weight of the fruit. So that potassium has to get into the pulp in order to promote growth. And what I'm saying here is that there's a much stronger correlation between potassium and the concentration of potassium in the pulp with fruit growth, the weight of mangoes. And this has been demonstrated. It's in the literature, and this is a reality. So when should I apply potassium? I'm going to show you some details here regarding when to apply potassium, because it should follow that growth curve to some extent. So now we're going to look at the project, what was carried out with the support of the National Mango Board, which is diagnosis and field management strategies to improve the size and uniformity of mango fruit in Ecuador, and Tommy Atkins. So the project was designed and approved by the National Mango Board to be carried out with Tommy mangoes. So we carried it out as planned. But the growers said, well, look, we also have some Ataulfo, and generally Ataulfos also have issues with size. So of course we can do it with Ataulfos as well and provide the support that we can. So of course we set out to do that because that clearly would be useful. So it was applied with Tommy and Ataulfo as well. So the first stage was diagnosis. The second stage was conducting field experiments. And the third stage was identification and recommendation, the best management strategy. So the first stage is diagnosis, which is extremely important because the first thing that we do when we really seriously want to solve a problem or help resolve a problem is to understand the problem. What is directly causing the problem? Especially because of what I mentioned, we see that fruit size is not the result of one single factor and there's no magic wand. It's rather the result of a series of factors. So we have to study those factors and understand those factors during the diagnosis stage so that we can then develop a plan. So we have climate data, historic climate data, farm management. We carried out different tests and evaluations on different dates regarding chlorophyll indices in leaves, electrolyte leakage in leaves. And this is very simple information, but extremely useful information because it's practical information and that indicates is an indicator of the stress that the leaves are under at a certain time. We also took thermal images. We looked at light intensity on a historical basis, soil resistance to penetration and soil moisture. We also looked at the nutritional status of the soil and leaves and the root system and trees in general. So I'll tell you a little bit about what we saw in Ecuador. So here we have a thermal images. We took thermal images at different times of the day and on different days. And what we're seeing here is a leaf that is at 30.2 degrees and with a variation of 26.2 to 32.4. Why so much variation? Well, you can see here that there are certain areas here in the photo, parts of the leaves, and there are certain areas that are covered and they will have lower temperatures. And the maximum was 30.2 here that we saw at this point right here. So this is considered a high temperature for a leaf at this point, at this phenological stage. At other times, perhaps not. We might see higher temperatures at different times, but at this point, this is a high temperature. And we can see the root system here in this orchard. This is an observation that we already had. And here we're seeing in the orchard, and you can see that there was only one micro sprayer. And something positive here is the leaves that we see down here. And I know some people will want to crucify me for this because here in Brazil, I have this discussion and disagreement often with many people because I recommend this when there are not problems with weeds or when you have a fertigation system and you can apply a mix of microorganisms that can act on these weeds that are present because the nutrition present in these leaves can be used by the soil, absorbed by the soil, and used by the tree. So something else you can see here in the picture, you can see where the micro sprayer is located. And when you apply water, you can see what's going to happen. This part here, you could consider it like a piece of pizza, slice of pizza. So this slice here is not going to receive any water.
And what will happen is that if the region does not have regular rainfall, this is going to decay and get to this point, and when this dies, it won't work anymore. So this is a very important aspect that we need to understand more clearly. Other variations were noted here. This includes soil moisture. This is a device that measures light intensity, as well as chlorophyll, total chlorophyll, chlorophyll A and B. We have other instruments that can measure electrolytes. And we're basically looking at everything that's happening on the tree. Over here, we see the chemical analysis prior to the initiation of the experiment. So look at the pH for Ataulfo and Tommy in the first evaluation, and then look again at the second evaluation. So if you look closely at this second evaluation, this is more approximate to the treatments that were applied. So when we talk about pH, we see a pH of 5.6 for Ataulfo and 6.3 for Tommy. So the Ataulfo required a little more observation. But let's look at this. The potassium saturation. This is 1.9, which is extremely low potassium saturation, which we don't recommend at all for mangoes. This needs to hover anywhere between 5 and 10. But we observed that it was at 1.9. So this then makes the situation more complex. And the magnesium saturation was extremely high. This should be only on the order of 15, no more than 20. So this makes the situation a little bit more complex. Another thing that I wanted to point out is sodium. For the Tommy soil, it was 1.8 and 3.1 for the Ataulfo soil. So when we look at electrical conductivity, I don't see it here, but at the time, the observation did not yield any concerns. But in that moment, we were able to measure sodium saturation. These numbers should be no more than 1. And sometimes the sodium can compete with other nutrients, and it changes the way the water accesses the plant. And so it can also react with the potassium at certain points in time, and this can also interfere with the potassium absorption. Remember that potassium is key for fruit size. So we see here the classification of soil attributes. We see here the numbers for Tommy's. So the MO was low. Potassium was low also, as well as sulfur. But some of these nutrients were above the expected results. For micronutrients, we just needed to pay more attention here. And what we needed to focus on here was boron. We believe that boron is interesting for mangoes because we could inject this into the soil. For Tommy, we have 0.78 and 0.4 for Ataulfo. The other parameters are basically within the prescribed ranges, but boron appeared to be extremely low, and you can see it right here. You could see iron here, and boron is below the prescribed range. So if we look at the nutrition, in other words, the portion that relates to the leaves, I color-coded this to be able to read it more easily. So if it's appearing in blue, then we're talking about levels that are within range. Anything in red is out of range. So we can see here for Tommy that we have a lot of out of range numbers. These are specific to Tommy. So we're talking about production levels of in excess of 34 tons per hectare. So for Tommy, we had nitrogen low, sulfur low, potassium low, calcium was within range, magnesium was below range, boron here was extremely low. I can't remember what the range was for Tommy and boron, but it should be at the very least above 120, and yet we recorded 52.5. So if you look at zinc over here was extremely low at 23.4. So we did compare what was observed between the soil and the leaves. When I showed you the soil classification, we saw more parameters in blue than in red, but now I'm seeing more red parameters than blue that pertain to the leaves. Now, soil moisture is another consideration. We see that light intensity was not extremely high. And I'm going to just say that this is a general standard measurement that we see. Soil firmness was 3.4 for Tommy. This soil was not really compacted, but we need to really be mindful of that soil. I use equipment that's portable, it's small, it's more practical, but it's got a top limit of 5. So it was averaging out at these numbers. Now, if you look over here at the leaf electrolyte leakage, we see 65 and 70. This indicates discoloration. And we started to see this on the ground. And this is information that's very similar to the other results that I showed you related to the thermal photographs. So these are the soil characteristics for Ataulfo and Tommy Atkins varieties. These are the historical data. And a few things really stood out for me here. This here, for example, look at what we're seeing here. The cloudiness percentage of time. The highest level of cloudiness as a function of time. We can see here that during this part of the year, the percentage of time where cloudiness was much higher was extensive during this part of the year. Once we got into the summer months, July, August, and September, then we started seeing a drop here, and then it starts to go up. So we did an experiment in September for one of the crops, and we had a period in which we did not have very high cloudiness for the production region, and that's the time in which we conducted the experiment. Now, we looked at the different stages and different treatments that were applied. And so we recommended maintaining the traditional management of the farm, T1. T2 included recommendations based on the plant's nutrition requirements in terms of quantity and following a phenological calendar. We recommended the use of fertilizers and a different distribution pattern based on the fruit growth rate. We also recommended adjustments to the irrigation, including KC. For treatment 3, we recommended the same thing, but over here we also added amino acids and phytoregulators. And this is a very relevant issue that you need to keep track of. The incorporation of amino acids, it's for spraying. And on several of these experiments, we applied this because we wanted to stimulate the growth system. That's why we added amino acids. T4 includes fertilization, irrigation adjustments, amino acids, plant growth regulator, and we also added a sunscreen. T5 was different because we recommended certain actions based on plant nutrient requirements, but it followed a phenological calendar using only liquid fertilizers. We used solid chemicals previously, but in this case, we switched to liquid fertilizers. Normally, these types of fertilizers tend to be more efficient, and they have a lower dose per hectare because of their efficiency. So we've been studying this in Brazil with mango trees in potholders. And we didn't work with large lot sizes, but the efficiency rate that we were able to identify for these liquid fertilizers was determined. We applied the same treatments to the plants in Ecuador, and we started on a farm in Ecuador. We used these fertilizers, and we determined it to be very efficient. So much so that the amounts of the fertilizer changed extensively. So we see here a table of the amounts of nutrients applied with each treatment using a fertigation system. So we see the different treatments to the farm. For T1, it was 57.36 kilograms of treatment. For T2, T3, T4 was 23.6, and T5 was 5.65. So this shows the significant difference here. Now, there was no recommendation for calcium application in this case because it was already very high, both in the soil and in the leaf. So we did not believe it was necessary to apply any more. And I thought that this would be the most efficient technical recommendations. If you see here, I reduced the application of potassium. The T1 averaged 40.39, and I recommended 28. And this was based entirely on the conditions in the soil and in the leaves. So we see here the recommendation table that was applied in the experiments. We see here the flowering, the application, weekly application proportions. So we made applications up to this week. The harvest occurred over here. And in the case of potassium here, which is applied 2 weeks prior to the harvest. Now, somebody might ask, why didn't you make applications further along to make an impact on the fruit? But the truth is, with 2 weeks left prior to the harvest, you're not really going to be able to influence the plant behavior very much. This is the table for the liquid fertilizers. I will be sharing this presentation with everyone so you can look at this with greater detail and perhaps subsequently ask questions. It's basically the same distribution. The only thing that changes is the amount of fertilizer. This is also the irrigation recommendation table that uses the historical transpiration data for Ecuador and in particular for Guayaquil. We made some changes accordingly. The amino acid source was applied on treatments T3, 4, and 5, and it was using Biomax, which is made up of 90% of free amino acids, and it was applied during flowering once during the second physiological drop of fruit and 2 more times every 15 days through fertirrigation with a dose of 250 grams per hectare each application. And this is a product, an amino acid product that has a very high concentration. Now, the phytoregulator that was used for treatments T3, T4, T5 involved a product called Biotech, which has cytokinins, gibberellins, and auxins to stimulate plant growth. The sunscreen was applied using this sunscreen that I've already used previously and that I've published results for in different countries. This was part of this work that was directed by the National Mango Board. So we conducted a single application of these products, and it ended up being 4 applications total. Now you'll notice that we switched the products that we used. Why did we change them? Well, this version of the product has potassium. So we made a foliar application with this particular product with the potassium. So if we move to the results from the chemical analysis of the soil, we see that for these areas that are outlined, these were the most significant results. We saw significant changes in the soil levels here. Between T2 and T5, we see much higher indices, and the same thing happened with all the other nutrients. Now, for potassium, for T1, it was basically the same, but there were increases in the subsequent treatments T2 to T5. Another thing that stood out was the amount of calcium. 14.4 before, then 4.2. Notice the drop here that occurred for T1. And for magnesium, likewise, there was a very sharp, extreme drop in magnesium throughout all the treatments. And we'll discuss a little bit more what we observed with that. In the leaves, what we observed was an increase in nitrogen, a significant increase in phosphorus. What happened was a little bit of an increase. T1 maintained the prior level, but T2 through T5 showed a slight increase. Potassium before was 8.5, but on the farm, T1 was 6.2, and then from treatments T2 through T5, we saw a couple of drops and then some increases. Now there's something here because the amount of potassium in the leaf is normal. It drops a little bit prior and slightly during the flowering before it goes back up again. So this begs that question, should we apply more to avoid this drop? And this is something that occurs if you increase the size of the fruit. This is going to cause this drop. Now, if you look at the ideal case, if you notice that the potassium levels are dropping too much, you'll see the results and you'll know what is likely happening. Either the fruit size is greater or the productivity is greater when we see a drop in this. Now, if you look at boron, which I already mentioned was already low, in all the treatments, this increased significantly. In zinc, when we look at zinc, the treatment on the farm increased extensively. The rest did not show any increase. So there was a bit of a differentiated trend there. Let's look at productivity now and the relationship with fruit size that is of most interest to all of you. Fruit yield on the farm was here in blue. This was the productivity or fruit yield for T2. It was a significant increase. The others also were higher, but slightly less than T2. So the productivity or yield for T2 increased significantly compared to the rest. So the treatments above T2, then T2 performed the best. But when we looked at fruit mass, and when this pertains to fruit number, but when we looked at fruit mass, this is very interesting because the farm level at T1 had this level, then the subsequent treatments. Then when we got to T5, we could see where we were, a fruit size that was much greater than the rest. But we have to look at this with great caution because there's a relationship that's already well known in the literature. And that is when you have greater yield or a lot of fruit, then the fruit size tends to be smaller. So we need to be able to assess this on a step-by-step basis. comparing the groups 1 to 1. So if you compare T1 with T2, T2, for example, showed 53.6% more fruit. But at the same time, it also demonstrated an increase in mass, averaging 5.5%. So T2 provided a larger number of fruit, and the fruit tended to be slightly larger. But when we compare the farm with T3, T3 yielded 25% more fruit and 7.5% more size. So look at what happened with T5, 9.8% higher number of fruit and 8.9% larger fruit. So you'll see that in all of the treatments, we had a larger number of fruit compared to the farm application, as well as slightly larger fruit. This was observed during the harvest. We were measuring the number of fruit as well as the weight of the average weight of the fruit. So when we see the results for Ataulfo, what we observed was that the results for Ataulfo were slightly different. But once again, T2 had a very high efficiency result. We see this here for number of fruits or productivity, production per tree. And over here, we have fruit yield, but it was slightly lower productivity. So the difference between T1 and T2 isn't that marked or that remarkable. But when we look at fruit number per tree, we see different results. Look at T5. T5 relates to fruit mass, and it shows much greater fruit mass for Ataulfo compared to the other treatments. This was significantly higher or larger compared to other treatments, and actually compared to many other treatments, including T4. So when we see this relationship where we compare the number of fruits with the fruit mass, what we see is that the farm treatment compared to T2, in T2, there was a 14.9% increase in the number of fruit, and there was an increase on the order of 7.7% in fruit mass. Comparing the farm with T3, we saw 2.3% more fruit and a 13.6% increase in fruit mass. For T4, we saw losses in both number of fruit and average weight per fruit. For T5, we saw a drop in the number of fruit, so it was a little bit less fruit on the tree, but look at the mass of the fruit that resulted with T5, 19.9% higher mass, average mass for the fruit. So I think this was a very interesting result for Ataulfo, and it's a treatment in which we used liquid fertilizers, better distribution, and as you can see here, we had a different irrigation with KC, amino acids, phytoregulators, and the sunscreen, focusing on fruit size, and it worked for one variety, but not so much for the other one. So Ataulfo responded to the treatments in a different way than Tommy did. Just to conclude, in the final stage of the project, the root system of the plants is not well developed and is believed to be insufficient to absorb the soil solution. It's necessary to use technologies to mitigate oxidative stress. Why am I talking about this? The reason is that we saw the data, especially we looked at the electrolytes, and in those cases where we used sunscreen, specifically T5, we saw some interesting results. The irrigation system with a single micro sprinkler per plant partially satisfies the crop's water demand. Not 100%, because we saw some soil samples that did not have sufficient water to favor fruit growth. Fertilization recommendations require adjustments not only in the quantities applied, but also in the timing and method of the distribution. And the current conditions of the orchards and the management practices are insufficient for the proper development of fruits intended to achieve larger sizes. So adjustments are necessary. So the general recommendations are as follows. We have to install a second micro sprinkler per plant and use other nutrients such as amino acids, which work really well. When we looked at the first farm in Peru, we also had very good results by adding amino acids to the soil. So that's an interesting track to undertake. We needed to be able to identify stress. The example of the sunscreen was very interesting. And some fertilization actions aimed at fruit growth allowed plants with a good fruit load to also have heavier fruit. So for that reason, it's recommended to perform soil analysis prior to the pruning and foliar analysis to support the formulation of specific nutritional recommendations for fruit filling. This is a very key point. Based on the results of the second part of the project, we recommend that for maximum productivity, you should apply the T2 treatment, which is fertilization according to nutritional demand by phenological stage and KC-based irrigation. This was particularly effective for Tommy. To obtain larger fruit and a higher commercial standard, apply T5, which involved a liquid fertilizer. So for systems that aim to balance productivity and size, apply treatment T3 or T2. And that's why I included various recommendations to fit the needs or desires of the grower. So we saw some efficient treatments for maximizing productivity and to maximize size and better market quality. Then we recommended other treatments. So a promising alternative would be to use T2 protocol as a technical baseline with adaptations towards T5 depending on the commercial objectives of the orchard. I wanted to highlight this because the continuation year over year of good practices will yield excellent results.
And it's always important to understand the orchard, to do evaluations, and to adjust the strategy. And with that, I will conclude. I would like to thank the National Mango Board, firstly, for their support in carrying out this project and for this invitation. I'd also like to thank Univas, Plant Soil, Ariegra, also the Ecuador Mango Foundation, which also was very important, and also Mr. Ronieran Oliveira da Silva. And this is our website and our Instagram account. And thank you very much for the invitation. And if you have any questions, I will be very happy to answer them. Thank you very much. We have time for a few questions. We're going to start with the first question from Dr. Maria Hilda Perez. Wouldn't it be important to apply potassium during the maximum growth stage according to the growth curve? when the cells are expanding? Yes. Well, with that treatment, we're talking about fertigation, and I would like to extend my greetings to Dr. Ilda. And so when we have fertigation in the system, so then we would be able to apply it in relation to the size of the fruit. If you are applying it directly to the soil, that's one situation. And if you use fertigation, you can distribute it more. So we did several applications from flowering through growth. And when we saw a weekly reduction in the fruit, we reduced potassium. And that curve that I presented is for Brazil. So that's important to know. So the fruit curve, let's see, the distribution is not going to change for anyone in the world. It's not going to change. What changes is the distance between one date and another. So this curve will have this shape everywhere in the world, but the distance of the weeks will change between countries and locations because it depends on the variety and the weather. So basically, that's the answer. Okay, thank you. So we have another question here from Dr. Victor Galan. The element of nitrogen on leaves and the reduction in calcium, does that lead to soft nose, the soft nose problem in Tommy's? No. No, because, and also my greetings to Dr. Sauco, to Victor. He's also a great friend. I did not see any problems, any soft nose problems. Calcium, well, when we started, calcium was already high in both in the leaves and in the soil. So I did not recommend it for that reason because it was already high. So we did not have that problem. Perhaps if we had evaluated the concentration in the pulp, it would be a closer value, but really we saw no problems, physiopathological problems in the fruit. Question from Gustavo Guevara. Where can we get the presentation? Well, we are going to include it on our website and we will publish a link. Also, we will send you the link. Also, another question from Miguel Encinas. How does thinning impact fruit growth? Great. Well, that's an important aspect to talk about in this experiment, and I didn't include this in the presentation because I included a lot of information, but in Tommy's, we did not do any thinning at all. But in Ataulfo, we did have to thin. Why? Well, there was an average of 10 fruit per panicle. That's too much. So there was a panicle with 12, with 14, and the tree really cannot deal with that. So that was done, and it was made standard at the farm. That basic thinning was done to reduce to 4 fruits per panicle, so half of the average. So an important aspect is that the closer to flowering thinning is done, it has a greater impact on the fruit size. That thinning cannot be done when the growth curve is on the upswing. In this case, it would have a very small impact. So the thinning must be done prior to the growth, the acceleration of fruit growth. And in that case, there is an impact. I'm not sure about the economics of this. Obviously, the cost benefit calculation will depend on the availability of labor in the specific location. But yes, it is effective. Great. Another question here from Dr. Reginaldo Baez. Is there any problem with lenticels related to potassium? Also, my greetings to Dr. Reginaldo. No, we're seeing that issues with lenticels occur at different times, certain times, according to weather conditions. Weather conditions help quite a bit, yes, but what is applied also has an impact, and the time of day when it is applied can also have an important impact. So we did not see any correlation between lenticel issues and the amount of potassium applied. But in other projects, other research projects, we have seen lenticel irritation in orchards depending on the dose of hormones and what hormones, primarily auxin. Application of auxin, it depends on the dose and when it is applied. This can have an impact on lenticels. Also, when ethylene is very high, when the ethylene goes up in the field, we also see greater problems with lenticels. I don't know if there are other factors involved that could be contributing to this lenticel irritation, but we did identify these factors in other research projects here in Brazil. Great. Next question is from Gustavo Guevara. In the case of Ataulfo, did you look at the data in terms of size distribution in T5 with T5? Yes, we did it for all the treatments. And since it's a very long presentation, we're talking about a lot of data. I didn't include all of the data in the presentation, but I can provide it to you. And when the National Mango Board posts the presentation, I can include all of it. The important thing, Gustavo, is that in the report, which I think is already on the National Mango Board's website, it does include the data, size data for Ataulfo. Great. Dr. Victor Paez again, very interesting. It would be interesting to repeat it with Mingolo mangoes in the Dominican Republic. What treatment do you think would have the best results in Mingolo mangoes in the Dominican Republic? Well, my greetings to you. I was in the Dominican Republic recently, a beautiful country. I have read a few things about Mingolo mangoes, and there is information in the Dominican literature. I've seen some things, but this would require more research, not necessarily a whole research project, but perhaps an initial evaluation in order to understand the region, the climate conditions, leaf soil conditions, and historical data regarding fruit size, and to understand what the factors are that could be limiting fruit size for them as well. Because what I'm seeing is that in the case of Guatemala, we saw one result. Peru was different, Ecuador was different, and there was a significant increase in fruit size in all of them, undoubtedly, but the recommendations are different. The recommendation for Guatemala was different from the recommendation for Ecuador. And the recommendation for Peru was different as well.
So for Mingolo in the Dominican Republic, perhaps you could collect more information or try one of the prescribed treatments and conduct an experiment. That might be something worthwhile doing. We have another question from Miguel Encinas. Is potassium one of the nutrients that has the greatest impact for the peat mango size? But to be honest with you, I don't think so. I think that for peat specifically, it's nitrogen. Because I see that for all of the fruit, nitrogen along with potassium to grow the fruit, primarily potassium, appears to be the most effective and contributes more to the growth of the fruit. But for peat in particular, I honestly don't believe that it's potassium. I think it's nitrogen. Why? Because there are situations, I honestly feel this way. I worked with Keith. I spoke during my presentation of 25 kilograms of per hectare, but I had an experience here in Brazil when the soil organic matter was high. We would do a pruning and we would know that we have a period of rainfall. So then I had a lot of organic matter and I was going to have a lot of rainfall during the fruit development stage. And I applied 5 kilograms of nitrogen per hectare, which is nothing. And the fruit that came out was large. So I don't think that for the specific case of Keat, and this is merely conjecture on my part, I don't think it's absolutely necessary for the Keat to use potassium. We hope to see you at future webinars sponsored by the National Mango Board. Thank you very much, Dr. Ítalo Cavalcante, for joining us. It was a real pleasure. Thank you.